Perfect. Well, let's go ahead and get started. So hello, everyone. Thank you so much for joining us today and welcome to the Bay Area Meetup. Today, we are delighted to have Matteo Merli presenting Pulsar without Zookeeper, introducing the metadata access layer in Pulsar. My name is Karen. I'm part of the Stream Native team, and we are recording this event today. If any questions come up, please don't hesitate to add them into the Q&A chat box. We'll try to address those towards the end of the presentation also. With that, welcome, and Matteo, please take it away.
Thank you, Karen, for the introduction. Let me share my deck here. I hope you can all see that. So the topic of today is on some kind of like update on things that we have been working on for quite some time. It's kind of like a long-term effort that has been going through, and it's still going on, and we plan to get that to some completion, hopefully very soon. And this is like more like how we interact with metadata, how Pulsar interacts with metadata, and how we interact with Zookeeper in particular, right? And so again, I reiterate the introduction, my auto introduction at this point. So I'm the CTO at Stream Native. We provide managed and hosted cloud services based on the Apache Pulsar technology with integration with different other technologies as well. I am the co-creator and the PMC chair for Apache Pulsar. I was at Yahoo, and when we created Apache Pulsar, and then I followed on through all the journey with Pulsar. I'm also a PMC member on Apache Bookkeeper, and I've been at Yahoo before. I've been at Streamio and recently at Splunk. So just to get started here, I just want to do some kind of like framing of the problem and the current status and what we want to change, where we want to get, and where we are. So first, like to frame the problem here, I want to see how Pulsar uses metadata. Like we always talk about data metadata, and for some people it's not really clear what is metadata or like how it is used, why it is needed, and so on. So if you take a look at Pulsar cluster, like this is familiar to anyone that is using Pulsar. There we have this concept of brokers and bookies that is clear, and also we have Zookeeper, and we say that Zookeeper, we use Zookeeper for coordination and for metadata. For a user perspective, a user just interacts with using Pulsar API, Pulsar client libraries to the broker, so it doesn't really know about metadata. It doesn't care. It is more like something that an operator has to kind of like be aware. So, but it's not clear to many operators even like what kind of metadata it is stored and why. So if you look at the data path, again, the data will always flow like from producer to brokers, get stored into Bookkeeper nodes, and then broker will dispatch data to consumers. So there is no interaction here with Zookeeper or with any metadata, and that is like when we are like at regime, that there is no like interaction there. But the metadata path is mostly like brokers and bookies will interact with Zookeeper. So, and while it is not on the data path, it's the service needs to maintain, needs to store and retrieve pieces of information that are related to the data or related to how do we function as a cluster, as a cohesive cluster, and both brokers and bookkeepers right now are like just reaching directly to Zookeeper and to use that as a metadata store and coordination. This is like within a single cluster, so each cluster will have its own Zookeeper cluster ensemble there, and this also becomes a bit more complex and complicated in the context of Geo-Replication. So now we have multiple regions. Each region has a Pulsar cluster, and each region has its own local Zookeeper, and there is also like global Zookeeper, which is a configuration store, and that is like shared across multiple clusters. So now you have like different metadata store at this point. some that are spanning multiple regions, so the picture here is a bit more complex, and how to deploy it and how to operate secondary system is not trivial. And so we say that brokers and bookies store metadata, but we don't know what that metadata is. So what is the metadata in this context? We have these are kind of 5 broad examples of what we intend for metadata. The main one is like a pointers to data. So we know that data is stored in certain nodes. We need to be able to find it. Or which data it is there available for me. So like all these is kind of like a metadata. Is like I use that as a pointer to discover where the data is physically located, either logically or physically located, into which node. Another common use case for it is service discovery. We need to know which servers are available in this cluster. We can have like a different variation on this theme. That could be like, okay, what are all the servers that were available? Which nodes are active right now? Which nodes are crashed? Which nodes are, for example, like storage nodes that are in read-only mode versus like in read-write mode, because, for example, like the disk filled up, but we still need to be aware that the data is still there. This node is up and active. It's just that is not able to take new writes. And a bit broader example here is the distributed coordination. So this is kind of like there are different variation on this. One example is like doing LeaderElection or like having distributed locks, and all these kind of use cases. We are also using the Metadata Store for slightly different use cases, which are like system configuration. I'll go a bit more, and provisioning configuration, like the user provisioning, like tenants, namespaces, and so on. So all of these, it is stored into this Metadata Store, which is Zookeeper today. So if you look at I talked about the pointers to data. So this is like one primary example here is that for each topic we have a piece of metadata, and that is handled by the managed ledger, which is a library that lives inside the broker. Essentially, the managed ledger keeps a list of ledgers. So each ledger is a segment of data in the topic, and this is finite. We roll it over after a certain amount of entries or size or time, and we need to keep a list of this. So in this case, like basically, we will keep a list in this metadata. Typically, this is like protobuf encoded, like in the example on the right, we have like a topic that has 2 ledgers with these ledger IDs, this number of entries and size. And with this information, we can know that if I want to read these particular entries, I have to open this ledger ID. So, and I have to ask a Bookkeeper client to say, I want to read ledger ID 1234, and that has 1,000 entries. So this is like one example of pointers to data. As I say, Bookkeeper also uses the metadata. So for each ledger, there is an associated ledger metadata, because a ledger can have different state. Like in this case, the state here, it is marked as closed. It might be something like an open ledger, so it will be marked open, and or in recovery. So there are like few states there. There is also like other information like ensemble size, write quorum, a quorum, and this basically means how many bookies are involved for this ledger, how many replicas of the data, what is how many writes we have to do, how many acknowledgement we have to wait for, and the length of the ledger, like which digest type, and also like the most interesting part here is the ensembles list. So this basically means that for different ranges of entry IDs, we know which bookies are assigned to these entries. Therefore, if I'm trying to read, like say, entry 10, I will look into the metadata and I will be able to figure out that entry 10 will be on both bookie 1 and 2. So I can read from either one of them. I can try from bookie 1. If that fails, I can try to read from bookie 2. And at the same time, like if I'm trying to read entry, say 1500, which is past 1000, at this case, this entry will be found either in bookie 5 or bookie 2. There's also like some additional custom metadata here that basically like we are marking that this is like this ledger is associated with a Pulsar topic. So this is mostly like for auditing or like for like backtracking this ledger and assign it to a Pulsar topic. This is like the main kind of the metadata that Zookeeper needs. We talked about service discovery before, like again, like what are the available bookies that I can write to, which of them are in the read-only mode. But there is also like, I want to discover like which broker owns a particular topic. So, or I can find the list of available brokers, for example, like so that you can use that information to for load balancer, for example, like if you have some kind of like load balancer, we can use that information to dynamically update the list of available brokers that new connection can be routed to. Another interesting question here for service discovery is also that we don't just need to know which brokers are alive, but we also want to know what is the load on each of the brokers. And that is important for the load manager component that will have to make decision based on this information. We'll make the decision of if I have this new set of topics to assign, I want to assign them to the list loaded broker with some fuzzing, with some randomization, but I want to basically skew on those list loaded broker to achieve like a uniform distribution of load across all the cluster. And distributed coordination, again, there's a bit of gray area here between like the service discovery and distributed coordination. Like there, in some cases you can view that as similar, but I wanted to have like a more emphasis here on two particular aspects of this distributed coordination, and which are again the locks over like a distributed lock over a kind of like resource. For example, like the acquiring the ownership of a group of topics. In Pulsar, we had concept of namespace bundles, which are actually like a shard of the namespace. So a topic will fall into a particular hash range. That means that that bundle and the brokers will take ownership of that bundles. To do that, they have basically to try to become the owner and validate that against the metadata store. And if that broker fails, that ownership will have to be automatically taken away. Also, like this is used by Zookeeper, for example, like for to coordinate the different workers in the auto recovery. So the Zookeeper auto recovery process is some kind of like a background job that monitors the health of the bookies. And if one bookie goes down, essentially like everything that was on this bookie node, it is marked as under-replicated. Now, essentially we have like a list of many ledgers that are marked as under-replicated. And now we have like multiple worker nodes that can cooperate and take a portion of this work and do it. But you don't want to have two worker nodes trying to replicate the same ledger. Instead, that you want to each of them to pick up different ledgers so that they can make parallel progress. But to avoid like this sidestepping, basically you are acquiring a lock over a ledger so that only one worker will do that kind of that work there. In the you can see also like LeaderElection is a slightly different case. The implementation can be done using a lock, but the logical usage is slightly different. So if for a lock you want to try to grab a lock on a resource and fail if you don't, if it's already taken, with LeaderElection is that different in the sense that you want everyone to try to become the leader. If they become the leader, they will do some special tasks. For example, like the load manager will have the leader will be the one that will make the decision at any point in time. At the same time, like if that leader fails, the argument will basically, all the followers will step up. One of the followers will step up and become the leader and continue there. And we talk about system configuration. So for system configuration, in this case, like we are talking about dynamic settings. One of the features that you can do in Pulsar is that you can override some of the settings in the brokers, like broker-wide settings or like a namespace-wide settings as well. But you can do that dynamically by run a command. You change the setting, and that setting is applied immediately without any restarting. There are like a potential usage of this approach, like having like I don't know, like some kind of like A/B testing of features and so on, or settings. But right now, basically, it gets activated everywhere, but without the disabling the brokers, and that's very powerful because like you don't want to basically trigger like a running restart on a very large cluster just to change the setting. Also, like we other like example of this kind of metadata are like the isolation information, so that which tenant should be assigned to subset of brokers, and also like the bookie mapping with the racks or availability zone. So this is typically kept in Zookeeper. A bookie will come up, will figure out I am in AZ A, so I want to mark myself to be in that AZ, so that the Bookkeeper client will know that the which bookies are in which AZ, and it will be able to pick up two different bookies that are in different AZ, so that we have redundancy of the data across different AZs. And the last one is the provisioning configuration. So this is kind of like the metadata for tenants and namespaces or topics as well. And so you have like all the policies that are created. You can say that this namespace exists. This namespace has this set of configuration that are assigned to it. And also like all the authorization ACLs are defined there for the default authorization provider. And this is kind of like highly cacheable metadata. We typically rely on caches so that we only read it infrequently, and this data is updated very infrequently as well. So only like when a new namespace gets created or a new tenant gets onboarded, this is when it gets updated. But this is like a very low write and a lot of reads, but all these reads are getting cached in the broker. So, okay, since the title and of this talk is about running Pulsar without Zookeeper, so what's up with Zookeeper? What are the issues there, and what do you want to do there? If you look at what Zookeeper is, basically it is a consensus-based database. So what it offers is like a consistently replicated database that stores data into a quorum of nodes. That means that the data will like you can survive n number like so you can survive like f failures if you have two f plus 1 nodes. So if you have a 3-node cluster, you can survive one Zookeeper class node failure. If you have a 5-node Zookeeper cluster, you can survive 2 failures, and 7 you can survive 3. That means that the data is, so each node will have all the data. So it is not horizontally scalable because all the writes will go through a leader. The leader will spread to all the rest of the cluster. if you add more nodes, you won't increase the write capacity. You will increase the read capacity because the reads are not going through the leader. The reads will go through any of the followers as well. But you definitely will not increase the write capacity and not even the storage capacity by adding more nodes, because each node will have all the data. The other thing about Zookeeper was that it keeps all data in memory, and once your data set will grow, it becomes like to be not very DC friendly. So there are a lot of objects. There's a lot of mix of short-lived versus long-lived objects. So that's kind of like not being very friendly with the JVM-GC. And also, like, one of the things is that it takes the entire snapshot of the data set frequently. So you can configure, so there are trade-offs there, but basically Zookeeper, it is based on the model of having a snapshot plus a transaction log. And each time you truncate the transaction log, you have to dump all the snapshot. Now, if you have like a multiple gigabytes, that you have to write it lots of times the same data. So there is no like a cost of incremental snapshotting here. So before continuing, I say that Zookeeper is really like a great example of engineering. It works really well for all the things that it was designed for. And some of the issue here that we have is kind of like when we stretch Zookeeper to work in a more sustained way, or like in a different way that is not different, but it's like in a slightly different way than when it was designed for. So there has been a lot of improvements on Zookeeper, both on the vertical scalability and how much data you can store of it, and but the main fundamental are kind of like always mostly the same. So for example, like since we say that it is not like a horizontally scalable system, like typically like you cannot store more than like 5 gigabytes of data into Zookeeper, and even that is like, I would say that this is kind of like our top. Even before like reaching that, once we reach into gigabytes of data, it is already like it is not trivial to tuning and operating a Zookeeper cluster with the gigabytes of data. So you can do that up to say 5 gigabytes of data. But it also requires a lot of knowledge of the Zookeeper internals, because like there are many tunables, but to understand the values of these tunables, you really need to understand how Zookeeper works, how the LeaderElection works. And so it is not easy. The other thing is that Zookeeper was designed and evolved in an environment where there were like bare meta nodes, there were no containers, also like mostly no VMs at that point, and then it got evolved. But like there are like a few subtle issues when you're running in containerized environments, and they're not always happening. It's just that depending on your configurations or like on the many different aspects, they can pop up here and there. But mostly like around like a DNS, the kind of errors that so the LeaderElection in Zookeeper it is really relying on some kind of errors and interaction between all these Zookeeper nodes that they can set the leader, they can sync up on what data they have, and decide that who is the best candidate to be the next leader, the next Zookeeper leader. So if you're running like in Kubernetes, you have a different DNS, and that is much more dynamic than what it used to be before. Like you had this static naming on your like this is Zookeeper 1, this is Zookeeper 2, and the IP will not change. Right now, the IP will change the DNS response. If that pod is down, that the DNS request for that hostname will fail when it didn't used to fail. Usually it failed the connection, but now it fails also DNS. So there are like these kind of like unexpected issues that you might pop up depending on the particular like DNS server implementation and so on. Also, that there are differences in the way that some SDN in containerized environment react with the connection errors, and that also can affect the Zookeeper LeaderElection, and that also goes even more south if you have a TCP sidecar proxy. Like for example, like if you have Envoy proxy or like Istio proxy to do like the TLS termination, that also like affect LeaderElection. And in all these cases, like the Zookeeper behavior is correct. So it is not that it does not work or that it fails or that it loses data. It's not like that. It is just that LeaderElection can take more than expected. And ideally, like you want to have LeaderElection. So if a Zookeeper leader crashes, you want to have a new leader within a few seconds at most, so that all the cluster operation can keep going. If that takes a few minutes, means that it can be a big problem on the cluster itself. So there's a lot of like environment testing and to make sure that everything works fine, and it's not always the case. So these are like kind of like the main operational issues on the running Zookeeper, either in cloud and containerized environment, and running it with bigger set of data. So then the question is, okay, why? What is the reason for Pulsar to that we are exploring and say that we want to run it without Zookeeper? So there will be like a couple of benefits depending on different point of views. If you're running a big Pulsar cluster, you don't want to have to be limited by the amount of metadata that you can store, because that means how many topics you can have or how many brokers you can put in a cluster, right? If brokers are horizontally scalable and bookies are scalable, you want to be able to add node indefinitely, or at least having that limit push much higher. If we have the metadata constraint that is not indefinite. On the other side, like if you have a small cluster, let's say that 3 nodes, you probably don't want to run the overhead of like running Zookeeper. You don't need, say, 3 more VMs or 3 more containers to run Zookeeper, and you have to deploy that and operate it and understand like the thing of Zookeeper. So they're kind of like different reasons for different point of views here. Finally, there are also like some of the issues are coming from how we are using Zookeeper and in Pulsar, and how that kind of like historically has kind of evolved since the beginning. Initially, like we had like really a tiny couple of places in which we were using Zookeeper, like mostly like Bookkeeper was using Zookeeper, so that was already a given. So that we figure out, yes, we can store other metadata in there, and then that's fine and everything. And then we kept adding like more and more usages of Zookeeper. And eventually what happens is that organically over time, that access to Zookeeper has been spread across most of the components in Pulsar, and but without a single centralized way to access Zookeeper. So essentially, like there's been like a creeping up of passing Zookeeper client handles around, and everyone is just using that handle, or then building caches on top of that handle. But there is really like no single point of connection to Zookeeper. That also makes it very difficult to, for example, like monitor how are we accessing to Zookeeper, like adding metrics and or like all this kind of stuff. The other thing is that we had a caching layer that is like Zookeeper cache, Zookeeper data cache, Zookeeper children cache. We have a mix and match of that, but that was not very good to begin with, and there is a lot of like mixing of synchronous and asynchronous operations in these layers, And the cache is kind of like something that doesn't feel like right on top of the Zookeeper. So you like if you want to do a read, you do the read through the cache. If you want to do a write, you do it outside out of band directly on the Zookeeper handle. Now you have issues that the cache will get updated when a watch come in and will do the invalidation, which is in background sometime later. So you can have like this manual invalidation in some cases, but not always. So it is not like a great situation there. Also, like there is no negative cache. So this can also be a performance problem, because if you have, for example, like someone trying to access metadata that does not exist, this will never be cached. So it will always be hitting Zookeeper directly with the read. So it's not a big deal, but we want to be able to cache that information so that brokers can respond immediately without asking Zookeeper. Yeah, and this one I already mentioned that there's no single point to collect metrics or to put any interception in the metadata point. One other problem that we have is that right now, like we kind of like we run on the safer side in the sense that if a broker loses the Zookeeper session, we want to kill the broker before it loses the session. And the purpose of this is that when the broker will lose a session, any resource that is owned by this broker will be reassigned potentially. So we don't want to run a broker when it's running some topic that is not owning anymore. So we kill the broker. So this is kind of like to be safer. The question is that we don't strictly need to do this, because bookkeeper fencing will ensure that if some new broker will take over the topic and we try to write on the same ledger, or like close the current ledger and write on the new ledger, that will fence the older broker out. So there's no like data, there's no race condition there anyway. But the main problems to solve are still that if a broker loses a session and does not restart, you have to have a mechanism in place so that you can try to reacquire the locks when the session gets restored. Or you want to have, since we are doing a lot of like version writes always, so that conditional writes, okay, update this value if the version is still at version 5 and so on. You want to make sure that if there was a timed out and write attempt, you have to basically resync with what version it is in Zookeeper anyway. So, and like all these cases, like if we don't have a single central access on Zookeeper, it is infeasible to do, because like we have so many places in the code that we have to implement this logic, and this logic, it is not really trivial. Also, like we want to have a way to say that we don't want to try to use Zookeeper for tasks that can be deferred if we don't have a session. So for example, like if we know that we don't have a session, we don't want to roll a ledger, because we know that that version will fail, so that we can defer it, so that is better to do it. So this was like the problem statement here, and we really thought about this for quite a while, and we kind of like defined several months ago like a plan that was like multiple steps. And the idea here is that the first step is to make sure that all the interactions are going through a single unified API that can be plugged with multiple implementation. Second step is to provide alternative implementation. So we start with Zookeeper, but we have multiple implementation. And the final goal here is to reach a point in which we can provide an internal metadata server implementation out of the box, so that you don't have to rely to any other external services. Again, one by one, we want to get through all these three steps. The first one, so there was so this was proposed in PP45. I think it's already some time ago, and this is already like 80% completed. The goal for this proposal was to have this unified pluggable interface that abstracts all the interactions, default implementation on Zookeeper, and also like 100% compatible with existing metadata. So you can basically, it is just changing how this in middleware layer, but the metadata will stay exactly the same as before for the Zookeeper implementation. Other implementation, of course, since they are like start fresh, we can define different formats and different layouts and so on. So the implementation of these is already 80% completed. So for the in 2.8 right now, in the current master, and the goal here is to get it fully completed 100% with the everything in for 2.9 release. The architecture here is that we have different kind of interfaces for these metadata, and so we have the Metadata Store, which is like a key value store access, and this is like dealing with byte arrays, for example, and user can register with for notification on data updates. There is an extended version of the Metadata Store that that is like for more advanced implementation that can support also ephemeral keys and values. On top of this, like a byte array, like row implementation API, there is also a metadata cache. So once you have a metadata store, you can create a metadata cache, and that cache will cache objects that are stored in the metadata store. Also, you can, with a extended metadata store, you can create a coordination service. Coordination services has like ResourceLock, LeaderElection, and distributed counter kind of features. This is the main breakdown here. And the main consideration for designing this API was that we wanted to have a kind of like high-level constructs. Yes, we have key values, but we also have say LeaderElection as a feature. It's not that you can implement LeaderElection by using key values and ephemeral nodes, but we want to have like one good implementation that exposes this high-level concept. Second is that we want to have all async APIs, no more sync APIs, and no more mixing sync and async, because this like makes everything much more complicated if you're mixing sync and the async. And finally, the main goal here is to was to kind of like nail down what kind of like semantic we want to support that has to be generic enough to be implemented by different backends. At the same time, we want to have it meaningful enough to be useful and easy to use from our components to use it. I will just show like these kind of like these APIs and how they look like. I will not go through in all the details, but so if you have metadata store, what you can do is that you can get keys, and you get like optional get result will return you the value of that key, and all these are returning computable futures. So everything is asynchronous, and you can use that and compose them in multiple different ways. You have the get children exist, and you can do a put, and the put can take an optional expected version. If you don't pass any version here, basically it will override whatever it is for that key. If you pass an expected version, if you do a conditional write on that key, so that if the version is the same, then we want to we update it. Otherwise, we don't. Also, like delete, you can delete only if there's if the version has not changed. And then there's like this a listener. Basically, I can register to be notified if there is any change in the data. Basically, my listener will be called, and I can use it in multiple different ways. Also, I can create a metadata cache. So the cache, basically, you can create one cache per each type for each POJO. For example, like if I'm trying to access policies for namespaces, I can create a get cache with policies, and by default it will be assuming the JSON serialization. So if you use JSON underneath, but all that part is done inside the metadata cache. So I just have to pass my own POJO class, and I get a metadata cache object. And with that metadata cache object, I can do most of the same stuff that I can do on the store, but now it is working with objects, not with bytes. So this basically encapsulates all the logic for the serialization and deserialization. So I can get the data, get the children exist. I can also do like these more complex like read, modify, update cycles. That basically means that I can it is doing this conditional write automatically without having to do anything special. So I can say I want to read the value of this key, apply my modification, and I'm giving you to the function. And I'm giving you a function that takes one T instance and returns a different T instance, and that will be done as a conditional write back on Metadata Store. And if there are like conflicts because of like two concurrent modification, it will internally retry so that will resolve that conflict. Let's talk about the coordination service. So coordination service is something that you can construct with the MetadataStoreExtended, and once you have coordination service, you can access either the LeaderElection service or the lock manager or the counter feature. So LeaderElection, again, not go through it. Is a bit more complex interface here, but essentially you want to try to do the election, and this is my purpose value, and we get a future, and then you get to see, you get to know whether that election you are now the leader or if you're a follower. And that really can change as well later on. You can lose the leadership and can reacquire it later. Lock manager, this is like what we use for resource locks, acquiring locks on some kind of resource. So you can either like read a lock without trying to acquire it, or you can say acquire a lock. At that point, you get a ResourceLock instance. Again, this is typed and it handles all the serialization for the values, but a ResourceLock basically represents a single lock that you have. So for example, like if I acquire the ownership of one bundle of namespaces, a bundle of topics, I will have one ResourceLock instance, and that we have one value. I can update that value eventually. And I can also track when this gets expired. So for example, like I can get notified if this lock is no more valid. And then I can, for example, like give up the topic. One thing that is very important here is that the LeaderElection and ResourceLock are already capable of revalidating the state. So if we lose a connection or the session is lost, when the session gets reacquired to Zookeeper, what they will do is that they will resync up with what I think I should have and what it is there in the metadata. And essentially, like, if nobody still doesn't own this resource, I will reacquire it. And if I'm successful, then nothing happened because I was the owner before. I lost the ownership, but nobody else took it over, so I can reacquire it. Or that might fail. I try to reacquire it, and someone else took it over, so I have to give it up. So I have to notify all the users for this LeaderElection or like a lock to make sure that they can give up what they have. And finally, so we have these two different implementations here, right? So we have the Metadata Store and the Store-Extended. So the store is basically like pure key value interface. So if you have to implement these interfaces, basically what you need is like a backend implementation that can support key value interface plus change notifications. The change notification is important to keep the cache updated automatically. The store extended basically added one more requirement, which is like the ephemeral keys. So that's what we need basically for the code coordination service. So if ephemeral keys will go away if the client code is gone. This is kind of like a roughly breakdown of what you could use as potential implementation, right? So for example, like MetadataStoreExtended, Zookeeper is the default implementation. We also have like in-memory implementation for unit tests, for example. Definitely, it is modeled to have a etcd implementation. We could also like envision like a RocksDB implementation of this, mostly for a standalone service. So it's not distributed, but we don't need to run Zookeeper to have the process standalone because it doesn't need any replication or any coordination. Everything is a single node. So that would be a good implementation for standalone. If you look at the Metadata Store interface, is the simpler one. You could also use things like DynamoDB or like even like a SQL database like MySQL, Postgres, or anything else. And I'm sure that would be a countless example of any key value store will be probably fit to implement that interface. So if you put like all these pieces together, like essentially what we have here is that within a Pulsar broker, we have all these components, like on the left, like the topic ownership, load manager, branch manager, and the API, and they will basically interact with these interfaces, either the Metadata Store for if they only need simple key value access, or the Metadata Store Extended if they're going to use coordination parts. These are going to be implemented with the Metadata Store implementation that will talk with the external service. One not to mention here is the Bookkeeper client. So Bookkeeper has already a pluggable metadata layer. The idea here is to bridge that layer into using the Metadata Store. And the reason is that we can basically reuse the same implementation for both Bookkeeper and broker accesses. So that is a kind of like an easy implementation. So we just basically build this tiny wrapper here that will basically use Metadata Store for Bookkeeper. So what is the timeline for all these changes? I say most of the change. Okay, I didn't complete the sentence here, but most of the changes are already in 2.8. Like most of the components have been migrated to use the Metadata Store interfaces. At this point, I can say like around 80% of it. And this is what is going on out in 2.8, which is like next week. We hopefully get to release it. For Pulsar 2.9, the target here is to have the Metadata Store fully implemented. Like all the components will fully migrate to the Metadata Store using the Zookeeper backend. At the same time, we want to basically add the capability of not stopping brokers when we lose a Zookeeper session. And for Pulsar 2.10, I like adding more alternative implementation of the metadata backend, like etcd, and also like previewing internal implementation of the Metadata Store. And ideally, we want to have this GA by like early 2022. So I talked about internal implementation. I haven't given many details yet. So the idea is that we want to provide this off-the-box implementation for metadata and coordination, and we are like working on kind of like identifying what is the best approach here. We have like in the hackathon there was like one implementation, basically like you want to do like a sharded consensus service. The reason that is sharded is that you can basically have a horizontally scalable throughput for that service, and you can do that based on Raft and having this collocated with the Bookie nodes, for example. Other approaches that we kind of like thinking through are like more like having like a traditional coordination service that kind of like bootstraps having a consensus service that can be used for the coordination part, which is not very intensive, but that can be used for bootstrapping a more like large scale key value DB, where the bulk of the data is. So basically, like the bulk of the data will store into this key value store, which is based on this consensus system. That is like that we have like a tiny amount of metadata. So this is kind of like the current approach that we are like working through, like either one or the other. That's working through like a proof of concept at this point. So I'm done with it. So I think that we have a lot of interesting distributed system problems here, about storage and distributed system. So anyone that is interested to work on these kind of problems, please reach out to me. We are hiring, so you can reach out to me on either on Twitter or like an email, or I'm also like active on the Pulsar-Lock. So feel free to reach out and to discuss any of these issues and so on. I'm like working on this kind of problems.
Absolutely. Well, Matteo, thank you so much for taking us through that great presentation. I'm not showing any current open questions right now. Of course, anyone who has any, please don't hesitate to reach out to us via contact us as well. And I just wanted to put in a quick reminder that the Pulsar Summit is going to be coming up this June 16th and 17th. We'd love to see anyone who has any interest in Pulsar whatsoever to join in for all of the great speakers that we're going to be having for that as well. So definitely take a look at that. We'll likely be posting up links for that registration as well. Oh, looks like I've actually got a couple Questions coming through. Matteo, are you able to see those questions also, or would you prefer I read them out?
Yeah, 1 second. I had to take the slides out, otherwise I couldn't see it. Anyway, so having encountered any performance issues on writing of metadata to Zookeeper on large scale cluster or with large number of broker topics. So the amount of the write IO, typically like we can control it in a way, because like even if you have many topics, you can control what the write rate is by having longer rollover time period. We had issues in the past with the write throughput on Zookeeper, and mostly things that were, I mean, in all those versions, that was like much worse than what it is now. Essentially, like the problem here is that we don't have many writes on Zookeeper, but if there is like, for example, like a broker failover with a lot of topics, there would be a spike of writes and spike of reads, and there were like a lot of contention issues on the Zookeeper client that will lead to like latency spikes and lower throughput there, and that have been like improved a lot in the 3.5 and 3.6 releases of Zookeeper. So that's kind of like, it's getting better there, but there are definitely performance issues once you have like a lot of writes and reads there. So what is your opinion about Kafka removing Zookeeper? I don't know. I was under the impression that they've been talking about that for like such a long time that I thought that was already done and released, but I just realized yesterday that it is not done and not released. So that's the only thing that I know.
Perfect. Matteo, thank you so much. Everyone, I'm putting in the link as I promised, if you're interested in taking a look at the Pulsar Summit page. We appreciate everyone being here. Matteo, of course, thank you for all of your expertise, and I hope everyone has a wonderful day.
Thank you, Karen, and bye.